Howdy folks, Mr. Koffler here with a quick lesson on how to calculate average atomic mass of an element given its isotopes. Remember, an isotope is basically a different version of an atom. So one element can have multiple versions of an isotope. Isotopes all contain the same number of protons but different numbers of neutrons, so they have all different masses. So let's read the problem we have here. Lithium has two isotopes. Lithium-6, its atomic mass is 6.015 AMU, and its relative abundance is 7.5%. And lithium-7, its atomic mass is 7.016 AMU, and its relative abundance is 92.5%. Use isotopic composition to calculate the average atomic mass of lithium. Now, remember, the average atomic mass of something is the sum of the isotope's relative masses, and an isotope's relative mass is its percent abundance times its mass. Fortunately, so let's start at the very beginning. Let's figure out what we know and what we don't know. So for lithium-6, we know it has a mass of 6.015 and a relative abundance of 0.075. All I did was I took the percent and I moved it to the decimal point to the left twice to put it back in decimal form. Now the same thing, let's establish what we know for lithium-7. It has a mass of 7. It has a mass of 7.016 and a relative abundance of 0.925. Once again, I had to take the percent I was given right here and move the decimal point over twice to make it back in decimal form. Now, to find that average atomic mass, we needed relative masses. And to find relative masses, we need percent abundance and mass of the isotope. Well, look at that. This question gave us both the masses and the relative abundances. So all we got to do for lithium-6, the lithium-6 relative mass is equal to 6.015 times 0.075, which is, let me plug that into the calculator, .015 times 0.075 is, it has a relative mass of, let's round it to 3 decimal places, 0.451. .451 or 415, sorry folks. Thought so, 451. Now, I'm going to do the same thing for lithium-7. Let me change the color of my ink so you can see the difference. So, lithium-7 relative mass is equal to it's equal to 7.016 times 0.925. And when we plug that into the calculator, we get 7.016 times 0.925, 7.016 times 0.925 is 6.48. Let's round it off at 6.490. 6.490. 6.490. So now we have a relative mass for both isotopes, and to find that relative mass, is all we got to do is take the sum. So 0.451 plus 6.490 equals 0.451 plus 6.490 is 6.941. And that is the answer. That is the relative mass. So let's walk through it one more time. First, I had to determine what my mass of each isotope was and what each of their percent abundances were. That was step one. Step two over here, calculate the relative mass of each of them. Relative mass is its percent abundance times its mass. And make sure you put percent abundance in decimal form. It's usually given to you as a percent, but you got to move the decimal over twice to put it in decimal form. So you multiply, do the calculation for each isotope. And once you have the relative masses of each isotope, all you do is add them together, and that is the weighted average atomic mass of the element in question. Notice, lithium-7 had the highest abundance. It's 92.5%. 6.941 is it's a lot closer to 7 than it is to 6. That tells you did this right. Because your atomic mass should be, your weighted average atomic mass should always be closer to the one with the greatest abundance. That's it, folks. See you in class.